Okay, in today's lecture we will see what is steady state stability. Okay. For example, if the machine is running at a constant speed and because of some reason, okay, maybe because of applying brakes, okay, or maybe because of any reason, if there happens acceleration or deceleration, means change in speed, okay, then the steady state will be vanish and transient period will start. Okay, I will show it in diagrammatically. Okay, where is whiteboard? One minute. Share. Okay. Suppose the machine is running with a constant speed or motor is running with a constant speed of 500 rpm. Okay, and we require to, or because of some disturbance, okay, because of some disturbance, the speed is changed to somewhat 510 rpm. Okay, but actually how the speed will change, okay, I will show it by other color. Okay, it will follow the curve like this. It will take some time to settle there. Okay, this is nothing but what? A transient period. Okay? This is nothing but what? A transient period. Okay, and this is, you can say that it is a steady state. Okay, and there is a disturbance of 10 rpm. Okay, and suppose again we want the speed equal to the earlier speed, that is 500 rpm. Okay, is what the machine should follow the same speed. Okay, what will happen, that is when the disturbance vanishes, it will come again to original speed. A minute. Okay, means what? Steady state stability is nothing but what? The machine is running with a steady state speed, constant speed, and because of disturbance the speed is somewhat increases or decreases, and after some time if the machine is able to come to previous position, previous steady state position, then we will say that the machine is steady state stable. Okay, do you get it? Machine is running at 500 rpm. Because of the disturbance, the machine speed has increased to 510, but the previous steady state point is at 500 rpm. Okay, so if the machine is again coming to 500 rpm after the disturbance is over, then we can say that the machine is steady state stable. Okay, here you can see that the definition of steady state stability: equilibrium speed of the motor load system can be obtained when motor torque equals the load torque. At this equilibrium speed, motor will operate in steady state. Okay, when we call the machine is working in steady state, okay, I will show you with equation. Okay, 1 minute, what happened? Okay, the fundamental torque equation is nothing but what? T is equal to TL plus J d omega m by dt. And this term, okay, this is the final term. Okay, this is the dynamic torque. This is nothing but what? Dynamic torque. Okay, and it is present only when, okay, d omega m by dt is nothing but what? A change in speed. Okay, this is nothing but what? A change in speed. Okay, means what? Dynamic torque is present only when there is a change in speed. Okay, there is a change in speed, and change in speed will happen only when there is a acceleration, there is a deceleration, or starting. Okay, only during these transient durations, okay, will cause the dynamic torque to present. Okay, means what? This equation is valid when there is a change in speed or dynamic conditions are there. Okay, this is a, we can consider this is a dynamic equation. Okay, but under steady state, what will happen when steady state is there? What will happen? Okay, steady state means what? There is no change in speed. Means what? The second term, this term will be equal to 0. This second term will be equal to 0. Therefore, this equation will become t is equal to t. Okay, so we can say that there, if there is a steady state, then t equal to TL. Okay, I will use one more whiteboard. Okay, it is given by Microsoft. Okay, where I can use infinite length of board. Okay, one minute. Just some wait for a minute. Okay, it is now appearing. Okay, it is appearing. I will open new problem. Okay, means what? The machine working in steady state, okay, indicates what? T equal to TL. T equal to TL means what? Motor torque developed in the machine is just enough. It's just enough to drive the load. To drive the load. Okay. It is running with a constant speed. We can say that it is running with constant speed now. Okay. And this speed is nothing but what? Equilibrium speed. This is nothing but what? Equilibrium speed. Equilibrium speed is there where motor torque is equal to load torque. Okay, we can say that the machine is operating in equilibrium. Okay, the same definition is given here. The equilibrium speed of the motor load system can be obtained when motor torque equals to load torque. Okay, at this equilibrium speed, motor will operate in steady state. Okay, at equilibrium speed, T is equal to TL, that is machine is operating in steady state. This concept is readily evaluate the stability of an equilibrium point from the steady state speed torque curves of the motor and load system. Okay, suppose we have speed torque curve of motor and also the speed torque curve of load. Okay, from those curves we can calculate whether the, or we can evaluate whether the machine is working in equilibrium and the equilibrium point is stable or not. Okay. Okay, we can take this example. Okay, for example, suppose this the curve denoted by 1 minute. Okay, curve denoted by T. Okay, this is the T. Okay, is, or I will draw this curve on whiteboard. Okay, so you can get it right. Same diagram I will draw here. The x-axis is speed, the y-axis is torque. Okay, there are two curves. One is the load torque, and other is the one is the motor torque, and other is the load torque. At this point, okay, at this point, I will show it by other color. Okay. This point, at this point, we can say that T is equal to TL. Okay, because it is an interjunction. Okay, at this point, T equal to TL means what? This is a equilibrium point. This is equilibrium point. Now we have to evaluate whether this equilibrium point is stable or not. Okay, suppose the speed at this equilibrium point, speed at this equilibrium point is omega m. Okay, and because of some disturbance, okay, because of some disturbance, the speed is increased to by amount delta omega. Okay, the initial speed is equal to what? Omega m. Okay, after disturbance, okay, after disturbance, the speed will become equal to omega m plus delta omega m. Okay, suppose this is the new speed. Okay, I will denote it by omega m1. Omega m1. This is the new speed. Okay, now if the machine is working in equilibrium, okay, steady state stability, then we can say that after, when the disturbance is vanished, the machine will again come to the original point. Okay, we have to check that. Okay, corresponding to this speed, the torque will be this. Okay, this is the load torque, sorry, motor torque T, and this is the load torque TL. Okay, I have to show it in on x-axis, because the on x-axis the torque is there. Okay, so I have to show load torque here. Okay, now at this omega m, at new speed omega m1, okay, what is their condition? T is less than TL. Sorry, this T is less than TL, and if T is less than TL, what will happen? The machine will decelerate. कळलं का? जर लोड टॉर्क जो असेल तो मोटर टॉर्क पेक्षा जास्त असेल तर ऑब्व्हियसली मशीन काय होणार आहे? डिसलरेट होणार आहे. लोड जास्त आहे आणि मोटरला जी दिलेली पॉवर आहे ती कमी आहे, म्हणजे काय होणार आहे? मशीन विल डिसलरेट. Okay, machine will decelerate means what? The speed of machine will going to decrease, and the original speed the machine will run with. Okay, means what? Here the equilibrium point is maintained. Okay, means what? We can say that this equilibrium point, suppose this equilibrium point is A, then we can say that the point A is stable equilibrium point. कळलं सगळ्यांना? पुन्हा कळलं नसेल तर पुन्हा एकदा सांगतो, विचारा. Anjali, are you there? Hello, Anjali.
Yes, sir.
तो कळलं का? पुन्हा एकदा सांगू?
कळाले सर.
ओके, फक्त काय झालं त्या ठिकाणी, टॉर्क ऍक्सिस आहे तो हॉरिझॉन्टल ऍक्सिस आहे, तो चुकून मी उभा दाखवला, तेवढाच प्रॉब्लेम झाला होता. ओके, आता ह्या नवीन पॉइंटला काय झालं? टी लेस दॅन टीएस झालं, म्हणजेच काय? मशीन विल डिसलरेट. आता उलट चेक करूया आपण. ओके, उलट चेक करूया. हे दोन्ही कंडिशन तुम्हाला चेक करावे लागतात. ओके, नाउ सपोज बिकॉज ऑफ some disturbance the speed is decreased. Okay, and speed becomes equal to omega m2. At this new speed, omega m2, okay, what you can observe, this is the load torque and this is the motor torque. Okay, this is the graph of motor torque. Okay, and this is the graph of load torque. Okay, so you can say that now for this new speed, okay, this is the load torque and this is the motor torque TL. Okay, and you can observe that now T is greater than TL. नवीन साठी जर पाहिलं तर म्हणजे हा पॉईंट जर पाहिला इथे येते व्हॅल्यू, या पॉईंटची व्हॅल्यू इथे येते, ऑब्व्हियसली ह्या पॉईंटची व्हॅल्यू ह्या पॉईंट पेक्षा जास्त असणार आहे. ओके, दिस इज द न्यू TL, दिस इज द न्यू T. Okay, that is T is greater than TL. Okay, means what? Machine will accelerate, okay, machine will accelerate, the speed will increase again and it will come back to original speed. It will come back to the original speed. Okay, कळालं? मशीन ऍक्सेलरेट कधी होईल आणि डिस्लरेट कधी होईल, तीच इन्फॉर्मेशन या ठिकाणी दिलेली आहे बघा. ओके, let us examine the steady state stability of drive of equilibrium point A. Okay, the equilibrium point will be termed as stable when operation, I will select pointer first. Okay, the equilibrium point will be termed as stable when the operation will be restored to it after a small departure from it due to disturbance in the motor or load. Okay, the original speed is omega m. Because of some disturbance by delta omega m, the speed is decreased, and these two are the new operating values of the load torque and the motor torque. Okay, let the disturbance causes reduction of delta omega m speed. At new speed, motor torque is greater than the load torque. Okay, for this condition, okay, if you can observe, for this case, okay, there, here is the T and here is the TL. Okay, if you project these two points on x-axis, you will get the value of TL and T, and where you can observe that here TL is less than T, means what? Machine will accelerate. Okay, means what? Speed will increase. Okay, so motor will accelerate and operation will be restored to A. Similarly, an increase of delta omega m speed caused by the disturbance will make load torque greater than the motor torque, resulting into deceleration and the restoration of operation to point A. Okay, we have seen that because of disturbance, if the speed is increased and the operating point is stable equilibrium point, then operation will again restore to original point. Okay, so we can call that, hence the drive is steady state stable at point A. Okay, whatever we saw the example, okay, we can conclude that, okay, these 4 points we can conclude. If the machine is working in motoring quadrant, okay, motoring quadrant means which? First and third. Okay, if it is running in first and third quadrant, okay, first quadrant is forward motoring and third quadrant is reverse motoring. Okay, in motoring quadrant, okay, T is greater than TL implies what? Motor will accelerate. If the motor torque is greater than load torque, machine will accelerate. And if the T is less than TL, the motor will decelerate, the speed will decrease. Okay, similarly in braking quadrant, braking means second and fourth quadrant. In second and fourth quadrant, okay, what will happen? If T is greater than TL, okay, in braking quadrant, if the T is greater than TL, indicates what? The machine is decelerate. Opposite आहे बघा, बरोबर याच्या एक करेक्ट अपोजिट आहे. मोटरिंगला काय होतं? if T is greater than TL, machine will accelerate, but in braking, okay, what will happen? if T is greater than TL, motor will decelerate. ओके, हे सगळं इमॅजिन करण्यासाठी तुम्हाला काय आलं पाहिजे? तर मल्टी क्वाड्रंट ऑपरेशनचं आपण लिफ्टचं जे एक्झाम्पल घेतलं होतं, ते एक्झाम्पल व्यवस्थित कळलं पाहिजे, तरच ह्या गोष्टी कळतील. ओके, सिमिलरली इफ T इज लेस दॅन TL, द मोटर विल ऍक्सलरेट. उलट आहे पूर्ण, याच्या पूर्णपणे हे उलट आहे. ओके, इथं डिस्लरेट आहे, इथं ऍक्सलरेट आहे. ओके, ह्या गोष्टी लक्षात ठेवा. ओके, किंवा इमॅजिन करू शकता, वाटलं तर तो ग्राफ पुन्हा मी दाखवतो तुम्हाला इथे. बघा हे डायग्राम मध्ये जर तुम्हाला दिसेल बघा. ओके, फर्स्ट क्वाड्रंट इज forward motoring. Okay, here the cage is, we have to lift it. Okay, cage we have to lift it, means what, the motor torque must, okay, must rotate the machine, means what, it is helping, okay, to accelerate. Okay, it is helping, means what, T is helping omega m, T is helping omega m. But in second quadrant, in braking, okay, this is forward braking. You can see that the empty cage we have to lift, and the empty cage will be lifted because of the action of counterweight, means what, the load torque in this case. Okay, load torque is helping speed, and the motor torque is opposing. Okay, the motor torque is opposing speed. Okay, here in first quadrant the load torque is opposing speed. यासच सगळ्या क्वाड्रंट मध्ये आपण पाहू शकतो. ओके, हे लक्षात ठेवायचं. ओके, in first quadrant motor torque is helping speed. Okay, means what, motor torque is helping speed to increase, but in second quadrant it is opposing. Okay, similarly we can examine the steady state stability of these 3 points. Okay, I will show here, or we will take that problem to whiteboard. Okay, I will take that problem to whiteboard. Okay, we can see that, suppose this is the equilibrium point. This is the equilibrium point where the speed is omega m. Because of some disturbance, okay, speed is increased. Suppose the speed is increased to omega m1. Okay, the new speeds, okay, this is the, new torques. This is load torque Tn, and this is motor torque T. Okay, if we project these 2 points on x-axis, okay, this is TL and this is T, we can observe that, okay, at new speed TL is less than T. TL is less than T means what, machine will accelerate. Hello, mute kara re. Machine will accelerate. Okay, machine will accelerate means what, at speed will again increase. Okay, means what, the operating point will shift away from the equilibrium point, means what, it is an unstable equilibrium point. कळलं का सगळ्यांना? कळलं का? अजून एकदा सांगू? आरती, हॅलो आरती,
हा सर,
कळलं का?
अजून एकदा सांगा सर.
अजून एकदा सांगतो. ओके, पुसाय पाहिजे फळा. ओके, बघा, this is the original speed. Okay, this is the original speed omega m. Okay, at this speed, at this omega m, what is the condition? T is equal to TLI, because they are in interacted there. Okay, दोन्ही एकाच ठिकाणी आहे, म्हणजे दोघांची व्हॅल्यू एकच आहे. ओके, मीन्स व्हॉट, टी इज इक्वल टू टीएल आहे, म्हणजेच आपण म्हणू शकतो की इट इज इक्विलिब्रियम पॉइंट. दिस इज इक्विलिब्रियम पॉइंट. नाउ वी हैव टू check whether this equilibrium point is stable or not. Okay, and suppose, so for that we have to assume that because of some disturbance the speed is increased to new speed omega m1. Okay, at this new speed, okay, if you can draw here, you can get the value of load torque TL and motor torque T. Okay, this is motor torque T, because this point is on the torque axis. Okay, motor torque axis, motor torque curve, sorry, and this is load torque TL. Okay, if we project these 2 points and x-axis, then we will get the values of those torques. Okay, this is the point of TL, this is the point of T. Okay, so you can observe that. Okay, what is the observation? TL जे आहे ते T च्या अलीकडे आहे, म्हणजेच काय आहे, TL is less than T आहे. Okay, which implies that if the motor torque is greater than the load torque, if the motor torque is greater than the load torque, then it is acceleration. Okay, acceleration means what? Speed will increase. Speed will increase. Okay, means what? Speed will further increase. Speed will further increase. Okay, means what? The machine operation is shifted away from this equilibrium point. Machine operation is shifted away from this equilibrium point. म्हणजे त्यापासून दूर दूरच चाललंय, ते जवळ काय यायलाच तयार नाही. Okay, means what we can say that it is a unstable equilibrium point. काल कार्ती LRT आरती अंजली,
हाँ सर.
हाँ काल ना. ओके, नेक्स्ट प्रॉब्लेम बघूया आता तसंच. Okay, in next case it is in the second quadrant. Okay, this is in second quadrant. Okay, second quadrant la condition काय आहे? What is the condition for acceleration and what is the condition for deceleration? It is just opposite. Okay, if TL is greater than T, then it is accelerating, and if TL is less than T, then it is a decelerating. उल्टा है पूर्णपणे इथं. Suppose the machine is running on with equilibrium speed omega m, and because of some disturbance, okay, we have to assume that some disturbance is there and the speed is increased to omega m1. At new speed, okay, this is the value of load torque T, because this is the curve of the load, sorry, this is the value of motor torque T, because this is the curve of motor torque. Okay, and this is the value of load torque TL. Okay, because this is the curve of load torque. If we project these 2 points on torque axis, then we will get the values of load motor torque and load torque. Okay, and from those 2 values we can see that TL is greater than TL. Here you have to go for its magnitude only, not the sign. Sign चं काही इथं काही consideration करायचं नाही. Okay, फक्त magnitude बघायचं. T is greater than TL means what? It is decelerating. It is decelerating. उलटा आहे या ठिकाणी second quadrant मध्ये. Okay, means what? The speed will again decrease and come back to omega m. Okay, means what? It is a stable equilibrium point. It is a stable equilibrium point. In third case, the third case हो गया. Okay, third case जर पाहिली, suppose this is the original speed, equilibrium speed omega m, and because of some disturbance the speed is increased to omega m1. Okay, Now they have interchanged the load curve and the motor curve. Okay, this is the load curve and this is the motor torque curve. Okay, at new speed omega m1, okay, this is the value of load torque and this is the value of motor torque. Okay, and from here you can say that here TL is greater than T. TL is greater than T in second quadrant means what? The machine is accelerate. Machine will accelerate. Okay, machine will accelerate means what? The speed will further increase. Speed अजून वाढेल. Okay, means what? The point will again shift away from the equilibrium point. याच्यापासून दूरच ऑपरेशन जाणार. Means what? It is unstable equilibrium point. It is unstable equilibrium point. कळलं का?